Hello everybody, you're very welcome to this episode of Programming and Algorithms. Continuing on really from opening and closing files, we're going to look at what's called exception handling. So how do we deal with if something unusual occurs? We have, in most programming languages, features that allow you to handle exceptions. So when an error occurs in a program that causes the program to crash, we call that an exception. We can say an exception has occurred, or Python raises an exception, something like that. What we don't want when our users are running our programs is if they get something like this kind of stuff. So if I try and open a file that doesn't exist, I end up with a big error message like that in the dialog window. That's not nice and that's not graceful. We can see in my code it says file pointer opens my data, but data spelled wrong. So it caused the program to crash. That's not nice, and we should never allow the users to see error messages like that. We should be able to catch the error as it occurs and then handle it in a different way. So in Python, to intercept an exception and handle it before the program crashes and exit gracefully, hopefully, we use what are called the try and except commands. So that's Python, try and except. So let's look at our code for opening a file. If we open a file called fakefile.txt for reading, and we print out the whole file and we close it, if we enclose that whole process with a block called try, and then if anything fails, if the open fails, if the read fails, or if the close fails, it won't crash the program. It'll jump down to the except part and it'll just print out something went wrong. So that's really helpful. Instead of a user being in the middle of a program and it crashing on them, it comes up with something went wrong. This is particularly important when you're asking the user to specify the name of files. So if they have to type in a file name or select a file and they select a wrong file name, then rather than crashing the program, it'd be just handier to say no such file exists or something like that. So we put the open in a try block, and in an accept block we have a message. We could do anything else in the accept block we like, but normally we just print out a message saying something went wrong. That's a bit of a generic message, but we'll see. We can specify more detailed messages as we go on. Conceptually, how we could think about it is, if there's no problem opening the file, then do it, else print something went wrong in the end. So that's how I think of the try and accept block. The try is almost the then of an if the if went right, and the else is the accept that something went wrong, if that helps. And as I say, if we ask the user to put in information like the name of the file, the number of characters, something like that, we can almost guarantee they'll mess it up because they're busy or they're hungover or they've got a cold or something like that. So if they type in the file name wrong, then we've got to try and catch that and handle it. So this is opening a file, as we saw before, without an exception block. Here's our code. What's the name of the file you'd like to read in? The path name is cpython34. The extension is .txt, so the full file name is path name of file extension. Then we open that file, we read it, and then we close it. So that's without our exception block. Now let's throw our exception block in. And it's just we stick the words try in front of the opening of the file and accept underneath it, and our exception here is print no file of that name found. So if the user types in a file name that doesn't exist, then they'll just get a message saying no file of that name found. So it won't give that big sprawl of an error message we saw earlier on. So that's much nicer, and it means we're in control of what happens with the program. There are all kinds of errors that occur though, and Python is able to detect what type of error or exception is occurring. It's able to detect I/O or input-output exceptions, file indexing, directory key, variable naming, syntax exceptions, type exceptions, argument, and divide by zero exceptions. So let's look at each one of those and the name Python uses. So for I/O errors, it's called I/O error, and it's raised or occurs, that exception occurs when we're trying to read or write a non-existent file. An index error occurs if I'm trying to read a value in an array, we'll say, and that value is out of bounds of the array. So if the array is 5 elements long and I'm trying to read element number 26, then it'll give us an index error. A key errors happen when a dictionary key isn't found. We won't worry about that one too much at the moment. A name error happens if a variable or function name that you're giving isn't found by the program. A syntax error occurs if there's a syntax error in the code. A type error happens when an inappropriate type is used. It could be a null or something like that. A value error occurs when an incorrect value type is passed in. And a zero division error occurs when I try to do a division and the denominator, the bottom part, is 0. So if I try to divide a number by 5, it gives me a value. If I try to divide a number by 1, it gives me a bigger value. If I try to divide a number by 0.1, it gives me a much bigger value. If I divide a number by 0.00001, it gives me a much bigger value. If I try to divide a number by 0, it'll give me infinity, which will crash the program. So we don't like dividing by 0. It causes problems, so we don't allow division by 0. And if we try to do a division and the bottom part, the denominator, is 0, we can catch that as a zero division error. So let's see one of those in action. Let's look at a value error. If I ask the user to input a number and then I print out whatever value it is, converting it into an int, if they type in B or banana instead of typing in a number, it'll catch that as a value error and it'll say, dude, you didn't type in a number. If they type in 4, this program will work and it'll print out the value input was 4. If they type in 46, it'll print out the value input was 46. But if they type in B42, it'll say, dude, you didn't type in a number. So this is a really handy way of checking if the user inputs a correct value. Let's try another one. So that's checking for a value error. We can check for multiple exceptions together by listing them in a single except clause. So if we do except type error or value error, then we can catch either of those type of errors occurring. What does that look like? Well, in this case, we're reading in a value, input value, and we're trying to print out the float of that. And if either a type error or a value error occurs, it'll say something went wrong. So in this case, what I've done is, just to make it easy, I've put instead of asking the user to input a value, I've just put in a for loop. And the for loop says, put in the variable input value, first put null value in, and then second put the string high in. So what the program is going to do is going to create a float, a numerical version of null, and that's a type error because that's the wrong type it's going in. And then it's going to try and create a numerical version of the string high, and that will cause a value error. So in either case, it's going to cause something went wrong. If I run this program, it'll say something went wrong, because neither none nor high should give us a correct numerical value. And in both cases, it'll give an error. We could also separate them out. So if we wanted to detect what specific error occurred, and let's try this case again. Let's have a separate except block for type error and a separate one for a value error. So here's our code. We're going to put 2 values into input value. First we'll put null in, or none, and second we'll put a string value in. So if we try to print out the float of the input value, the first time when it reads in null or none, it'll say that's a type error. So the print message in this case is type error : dude, you typed in a null value. And then in the second case, it'll try and read in a string and convert that into a numerical value, which it can't do. So then the second time it'll catch a value error. It'll say value error: dude, you typed in some characters or a string of characters or something like that. So we can't convert nothing into a numerical value. It would be tempting to convert it into 0, but none is not the same thing as 0. If we want to tell the program 0, we should put 0 in quotes and then convert that into int or float the normal way. But we shouldn't try and convert null or none, because that's nothing. So we can't convert nothing into a numerical value. It would freak the program out too much. So the messages will be that trying to create a float of none and trying to create a float of high don't work. It is a fact that the system the program also detects information about the error that has occurred. So as well as the print message you can put in, the system creates a message as well. The reason it knows what type of error that has occurred is because Python tells the operating system, oh, this type of error has occurred. So if we wanted to save the Python error message, we could say, have our accept block, let's say for a type error, and if we say as sys message, then we can print out that system message. So this isn't a message we're generating. This is a message that the system, or in our case, the Python compiler, is passing to the program to let it know what kind of error has occurred. So if we did our same program again, none and high, and we tried to convert them into float, and we're catching either type errors or value errors, and we're catching that system message as well. If we print out something went wrong and then whatever the system message was, what we will get is something went wrong and then it'll say system message, float argument must be a string or number, not a null, because that's the system message that Python has generated for the first one, which is the none, and for the string high, the system message that Python generates is could not convert string to float high. So Python is actually excellent in terms of the detail it captures of the problems with the program. So it's told us exactly what's wrong. So rather than us having to figure out what the type error was or what the value error is, if we just captured the system message by using the phrase as sys message after the accept, then we can capture precisely what Python thinks has occurred. And this is very important. Anytime we ask the user to type in anything, anytime we're outputting to a file, if we have to assume the file is there, then we should always do a try and accept block to catch, because the chances are once we let the user mess with our code, they'll do something silly. Last one, just to say that as well as the accept block, we can have an else statement as well. And what the else statement in the accept block means is print out the accept message if an exception has occurred, else print out a message which indicates that no exceptions have occurred. So if we wanted to ask the user to input a value and they type in a value correctly, let's say they type in a value wrong, it jumps to the accept block and says, dude, you didn't type in a number. Else the value input was and whatever the value was, so it'll only print out the else part if they did type in a number. So that's another way, if we want to have in the accept block and else, we can do that. We could also just put that print statement up after inside the try block, but if we want to have it inside the accept block, we can do that as well. So there's a lot of flexibility in the way Python handles exceptions. I'm only scraping the surface of this. There's a few other commands you can do in conjunction with the accept, but for our sake, our only interest really is that we're aware that when we're opening or closing files, when we're asking the user for input, we should put that in a try block, and then we can have an accept that will print out a message if something goes wrong, and we can capture the system message by using the as command. So in this case, an else statement after the accept block allows the program to let the user know that the try statement is successfully executed. Absolutely. So that's exception handling. Thanks very much. We'll see you on the next episode.